I want to explore Lasso regression with a simulated dataset in R. We have n equal to 10,000 observations. I draw an error term epsilon and variables x1 to x5. And the dependent variable y shall be a function of these x1s to x5. So they appear linearly here, at least some of them. And we also have some interaction terms, like x1 multiplied by x2 or x1 multiplied by x4. And I put everything together in a data frame called dat. So let's forget for the moment how we generated the data. Let's just assume we start with this data frame dat and want to develop, using Lasso regression, a prediction model that helps us to predict a good value of y if we only know the values x1 to x5. The first thing we do is we should separate our dataset into a training dataset and a test dataset. I want to specify the number of observations in our training dataset, so one often uses a number like 80% of the total observations, so it's 0.8 times the number of rows in our dataset. And let me round this number in case the number of rows would not be such a nice number like we have here. So here I would put 8,000 observations into the training dataset. Now I want to sample random rows from our dataset that shall be the training dataset. I use the function sampleInt, and its first argument is kind of the total numbers. That will be n. And the second argument is how much rows I want to sample. That would be n train. And now train rows basically is a vector that has 8,000 observations, and these are all the rows that shall be part of the training dataset. Now I specify the training dataset as all the rows of that which I have in this vector train rows. And the test dataset shall consist of all the remaining rows. So I just can write here minus train rows. We need an R package to estimate a Lasso regression, and there are different R packages one can use. One that is very often used is called glmnet. So there's no Lasso in the name, but basically it's a package that can estimate a more general class of models called elastic net models. But our Lasso model is kind of a special case of it. And this function library has a function with name glmnet. And I press F1 to get the help of it. It's already open here. And I see the parameters. The first parameters are x and y. So it's actually not a formula we provide here. X is basically the matrix of all explanatory variables, including all the interaction terms we want to estimate or polynomial functions. And y is just the matrix of the dependent variable. It's also often called response variable. So we cannot really use here a formula interface. We have to construct our matrix of explanatory variables ourselves. And let me construct this for the whole data set dat, and then I extract the matrix for the training data and the test data. I use the function model matrix. That's actually a function in the basic R package stats, and we can give it a formula. So that would be actually our regression formula. And assume we want to regress y on all the x1 to x5 and all possible interactions between x1 and x5. One can write it in this way. I write x1 plus x2 plus x3 plus x4 plus x5. And then here just say a square. And I have to provide a data set. I say data equal to dat. Let me take a look at x. It's basically now the matrix, like in a linear regression model, of all the explanatory variables I use. So we have an intercept, the value is x1 to x5, and here we have the interaction term, so that's just x1 multiplied by x2. And we don't have the square terms x1 multiplied by x1, probably the R constructor thought you don't add so often square terms. You rather add these interaction terms, so we don't have them. But we also don't want to have them in our lasso regression. Now we want to have the X matrix for our training rows. So I should say X train is equal to X. And I take all the training rows. And for our test data set, I would take all the test rows. Good. Now we can, oh, sorry, not test rows. I must say minus train rows. So let's call this function glmnet now with the X argument, that would be our matrix X train, and the Y argument would be the column Y of our training data set. And let's also specify the parameter lambda. That's kind of this regularization parameter. Let's just set it for the moment equal to 1. And let's save the result in a variable called lasso1. And let's run it. So we have a result. We can take a look at it. But it's not so informative. We could try a summary. It's also not very informative. Let's instead load the library Broom and use the function tidy on lasso1. And here we get a result that's more similar to what we would expect from a linear regression. We essentially have a term, intercept, and x4, and we get a parameter estimate. But interesting, we only get estimates for the constant and for a coefficient in front of x1. But we had many more terms in our explanatory variable in our matrix X. So all the x1 to x5 and all the interaction effects. Why do we see only so few coefficients here?